guys, we're going to try out videos this week and see how it goes. I will try maybe to do live streaming next week so that you can ask questions as we go, but I figured this at least would be a good way to start out and see how it works for us. Okay, I do encourage you to ask me questions either from this or your previous assignments and such if you have them. Just email me and we can set up a Zoom or just talk over email as well. Okay, so what I want us to do right now is just do a quick review over our logs, and then we're going to put the two review parts together to be able to start solving more complicated logs. Okay, so today you don't have an assignment, you're just trying to get comfortable and ask any questions that you may have. Okay, so let's go on over to the Elmo and see what we can do here. I will be uploading these notes to Google Classroom as well, so you will have access to those if you would prefer, or you're welcome to take your own notes, but however you do it, just make sure that you have a way to access this again. Okay, so today we're going to look at more complicated logarithmic equations. Okay, that doesn't mean they're hard, they just look harder. Okay, so, but first we do want to look at just a review, okay, over the past week or so. Okay, and if you haven't finished your assignments, maybe this will help you out a little bit. Okay, so those due dates are flexible. I will be contacting you if I am not seeing you getting work done, but if it is just because you don't understand, then hopefully this will help make it a little bit easier as you go. So let's review some of our properties. Okay, so let's take log base 2 of 10 plus log base 2 of 102.4. Okay. So here we have, and I'll try to get that where you can see a little bit better. Okay. So here we have an addition. Can you remember to yourself what we do when we have an addition? Okay, that's when we multiply. So we take log base 2 of 10 times 102.4. Okay, and then we simplify our multiplication problem, which gives us 1,024. Okay. And then using our chart, or if you need to, you can use your calculator, but we want to know what power of 2 makes 1,024. Okay. And it should be 10. So there we used our logarithmic property to simplify something that we couldn't before. Okay. So let's look at another one. So we have log base 5 of 500 minus log base 5 of 4. Okay. And I did forget to mention, make sure you're taking breaks every 15 minutes or so. I know it's a pain to watch a video, okay, but just make sure you get up, take a quick break, and then come back, okay? I don't expect you to sit through the whole thing in one setting. Okay. So we are looking for a sign here, and what we have is a subtraction. And so subtraction goes with division. So we take log base 5 of 500 and we divide it by 4. Okay, so we have the 500 divided by 4. And using our calculator, it's fine. We get 125. Okay. So now we're asking ourselves, 5 to the what power is 125? Okay. And I don't always put this step, and that's because at this point, you should remember that that's what we're doing. Okay, but if you need to put the step, that's fine. So 5 to the what power is 125? And our answer is 3. Okay. And then a final example of those 3 properties that we were looking at last week is log base 5 of x squared. Okay. And in this case, we're just rewriting it. Actually, let me change that so to mirror more of what your assignment was. So let's take log base 5 of 625 to the 9th. Okay. Now, could we take 625 to the 9th in our calculator? Possibly. And I did here, okay, and it's a huge number. Okay, so that is a possibility. However, we can do it a little bit easier by using our power rule, okay, which just says we bring that power down to the front. Okay, so we get 9 log base 5 of 625. Okay, because when you have a power to a power, we multiply. And if we find out this exponent, what it is, so 5 to the what power is 625. Okay, our answer is 4. So we take 9 times 4, because the 4 replaces that. Our answer is 36. Okay, so that is what you were doing last week, last Thursday and Friday. We're dealing with that. And so hopefully that clears out any issues that you had. If not, please let me know, okay? Because we will still be using at least those concepts today, okay? Next, let's step back even a little bit more and look at some basic logarithmic equations, okay? And all that says is over there is review, if you're wondering, okay? So let's look at this equation and see if we remember how to solve it. Okay, so log of 2x plus 1 equals 2. So this is one of the simple cases that we had of logarithms. And in this case, we have one logarithm equal to a number. So what we wanted to do was rewrite it as an exponential. And to do that, we had to look at our base. Okay, and so sometimes we have a number here, sometimes we don't. But when we don't, remember that that means 10. Okay, so we set this up now. 10 to the second power is equal to 2x plus 1. Okay, so now we have an equation that we can solve, hopefully. Okay, so 10 squared is 100. We have 100 equals 2x plus 1. And so now all we have to do is get x by itself. So subtract 1. Okay, and then we divide by 2. So we get 99 halves is perfectly fine. Okay, or what is that, 49.5? Okay. Now remember, we do want to check. We can only take logarithms of positive numbers. So we have to make sure that this is a positive number in the parentheses. Okay. And we are taking 2 times a positive number and adding 1, so it's definitely positive. So this is our answer. Okay. So we can solve simple logarithmic equations that have a log on one side and a number on one side. Okay. The other kind that we already know how to solve is when we have a log equal to a log. So let's say we had log base 3 of 5x plus 2 is equal to log base 3 of 2x plus 1. Okay, so this is the other scenario we had. Okay. Now in this case, since they had the same bases, all we had to do was drop the logs, okay, and it became just the parentheses equal to each other. So we have 5x plus 2 equals 2x plus 1. And if we get the x's on one side, this would be 3x. And if we get the numbers on one side, this is negative 1. So we get x equals negative 1/3. Okay. Do we have to throw a negative number away immediately with logs? No, we plug it back in and see if the quantity is negative. Okay. So if we take 5 times negative 1/3 and add 2 to it, we're still good. Okay. And if we take 2 times negative 1/3, that's only negative 2/3 plus 1, so we're still good. Okay. So there's our other scenario. Now, when we get into more complicated logs, we want it to look like these two scenarios. Okay, either one scenario equal to a number, or a log equal to a log. Okay, so keep that in your head. You're trying to make it look like the things that we've already done. Okay, so that's going to be our job today. And we're going to work through a few examples. Okay, and my request is that you work through them and see what questions you have. And you could email me the questions you have, or we could Zoom if you wanted to, because this is what your assignment will be on tomorrow and maybe even the next day. We'll just kind of see how it goes. Okay, so let's summarize that. When we have more logs, okay, so if it doesn't match our two scenarios, okay, our two previous scenarios, we want to use properties to rewrite, okay, so they do match. So again, we are looking for a way to make it either one log on one side with a number on the other, or one log equal to another log on the other side. Okay, so let's look at one here. So we have log base 3 of x plus log base 3 of x plus 6 equals 3. So what's different about this one is we have two logs, okay, but they're not on different sides. And so we've got to either make this, move our log to the other side, which would be fine, except now we have this hanging 3 on. That doesn't work, okay? Or we try to get one log on one side and a number on the other, okay? So let's ask ourselves, is there any way to make this sum of logs a single log? Okay, and if we think about that first problem that we did at the beginning of class, okay, where we had a plus, okay, do you remember what we did? All we had to do was change that to a multiplication. Okay, so let's change that to a multiplication. So we take log base 3, and we have x times x plus 6. Okay, so we're going to change that plus into a multiplication, since we have a single log, equals 3. Okay, so that's all we had to do is we changed, because of the rules of plus turns into a minus when we have a single log. Okay, so now let's go ahead and multiply that out. X times x plus 6 is x squared plus 6x, okay, and it's equal to 3. So now we have a single log on one side and a number on the other side. Now sometimes we forget what to do, okay? Well, once we have a single log, all we have to do is rewrite it as an exponential, okay? So to rewrite it as the exponential, we need to go find the base, which is 3. So 3 to the third, okay, equals x squared plus 6x. Now, I know they're not your favorite, but we do have quadratic, so we need to move everything over to one side. So we have x squared plus 6x, and 3 cubed is 27, and so we subtract it. Now, we can factor or use the quadratic formula or completing the square, whatever works best for you. Okay. In this case, I'm going to factor. So two things that multiply to 27, okay, and add to a positive 6. Okay, and since they have a negative 27, we're going to have one of each sign. Okay, and the positive wins out, so that means the negatives must be the small number. Okay, but whatever, however you factor. Okay, but you're looking for two things that make a negative 27 when multiplying and a positive 6 when you put them together. So hopefully you came up with x plus 9 and x minus 3. Then we use our zero product property to say that x is negative 9 and x is 3. Okay, now we have to go check, can we keep both of these answers? And in this case, no, we can't, because if we plug in negative 9 up here for x, that's taking a log of a negative, so we can't have it. Okay, 3 works okay here, and 3 works okay here, so it looks like 3 is a good answer. Okay, so all we had to do was find a way to rewrite this to make it look like the ones we've already done. Okay, so let's see if we can do another one. So what about log of 5x minus 1 is equal to 2 plus log of x minus 2. Okay. So again, this one has two logs and they're on opposite sides, which is great, except for the 2. Okay, that does mess things up. We can't just drop our logs. Okay, so we want to rewrite this as one log. Okay, so I'm choosing to move this one over so that I can just keep my 2 here. So we're going to move it over to the other side, and so we'll need to subtract it. So we have log of 5x minus 1 minus the log of x minus 2. So we moved it over, okay? And that's equal to 2. So now at least we have our logs on one side. Okay, what do we do when we have a minus? We divide, okay? So we have log of 5x minus 1 on top. So the left one always goes on top over x minus 2 on the bottom. Okay. Now, if you were to move your logs to the other side, this would be reversed, and that's okay. It all works out. Okay, but I tend to try to keep this number positive, but you do whatever works for you. Okay, so now we have this log is equal to 2. And again, when you have a single log equal to a number, we just rewrite it as an exponential. Okay. Oops. That's all that says, rewrite it as exponential. Okay, so first thing we need is a base. So what do we use for a base when it doesn't show up? Okay, we use a 10. Okay, so we have 10 to the second equals 5x minus 1 over x minus 2. Okay. And let's go ahead and simplify. We know 10 squared is 100. Okay. Now what do we do? I know this seems kind of strange. Okay. This is where we cross multiply. Okay, let's get those x's up where we can work with them. Okay, so we get 100 times x minus 2 is equal to 5x minus 1 times the bottom left, which is just 1. Okay, so when you get to this point and you have x's on top and x's on bottom, all you have to do is cross multiply. Okay. So we get 100x minus 200, okay, equals 5x minus 1. Get x's on one side, numbers on the other. So here we get 95x. And if we add 200 to a negative 1, we get 199. Okay, and then our final step would be to divide. So we get 199 over 95. Okay. And if we check up here, this will definitely be positive, and this is positive as well. Okay, so that's a little bit over 2, I believe. Okay. So our goal again was just to get it as a single logarithm on one side, and we used our properties that minus becomes a division when you write it as a single log. Then we cross multiplied, and then we solved it as usual. Okay. So let's go on to another type. Okay, so let's actually, why don't you try this one? Take a minute and see where you go with it. Okay, if you need a break, go take one. We're only going to be on here a couple more minutes. Well, maybe about 10 minutes. Okay. So I have 1 plus the log of 3x minus 1 equals log of 2x plus 1. Okay, so I'm going to pause this a minute and you go try it, and I will, during that time, have the answer up here and you can check it. Okay. So go ahead and pause your video if you need to, and then unpause it when you're ready to check your answers. Okay. So here, move that over. And again, the reason I chose to move it this way was because I wanted my 1 to stay positive. And then I do have a division, so I am going to divide. Sorry, I have a subtraction, so I'm going to divide. I said that wrong. Okay. And I have a single log, so I'm ready to write it as an exponential. So this is 10 to the first equals 2x plus 1 over 3x minus 1. And 10 to the first is just 10. And now we cross multiply. So 10 times 3x minus 1 equals 2x plus 1. Okay. So we get 30x minus 10 equals 2x plus 1. And 28x equals 11. So x is 11/28. Okay. So how did you do? Okay. I'm sure you did fine. If not, send me an email, right? And we will figure out what's going on. Okay. So let's look at one other type that can show up. Okay. And that's where we end up having a log on both sides. So let's look at the natural log of 1 minus x plus the natural log of 3 minus x is equal to the natural log of 8. Okay. So notice here we have logs on both sides, and we just can't drop immediately because we do have that plus. Okay. Now when you have logs on both sides, it's just probably best to leave them like they are on each side and then combine the one that has multiple into one. Okay, so this one has 2 logs and this one has a single log, so let's leave this one alone, but let's combine this one. Okay, so what do we do when we have a plus? That's right, we want to multiply. So we take 1 minus x times 3 minus x equals natural log of 8. And we could go ahead and multiply this out. So 1 times 3 is 3, 1 times negative x is negative x. Negative x times 3 is negative 3x, and negative x times negative x is x squared. Okay. And we can keep simplifying. This becomes x squared minus 4x plus 3 equals natural log of 8. So now we have a single log on both sides. This is where we just get to drop them off, the natural logs or the logs, whatever they happen to be at that time. Okay, so we just now have x squared minus 4x plus 3 equals 8, and we solve it like a quadratic, a normal quadratic. So we could try to factor, quadratic formula, whatever works. Okay, except I wasn't looking, we better move that 8 over. Okay, we do want the 0 on that side. So x squared minus 4x, and if we subtract 8, we get negative 5. Now we want to factor or use a quadratic formula. Okay. Two things that multiply to negative 5 and combine to make negative 4 when you add them would be a negative 5 and a positive 1. Okay. So x minus 5 times x plus 1. But if we solve for x using that 0 product property, don't forget that. We get x is 5 and x is negative 1. Okay. Now you do want to check. Now if I plug 5 up here, I get 1 minus 5, and that's a negative 4. Okay. Anytime we get negatives with logarithms, right, that can't happen. So although we had a positive answer when we put it up here, it made it negative. Okay, so that doesn't work. And then if we have a negative 1, 1 minus a negative 1 is 2, so we're good. And 3 minus a negative 1 is 4, so we're good. So negative 1 is okay. Okay. And our final problem of the day, let's look at log of 4 minus x equals log of x plus 8 plus the log of 2x plus 13. So this is similar to the one we just did, okay, because we do have logs on both sides, no extra numbers, if you will. This time our single logs on the left. Okay, we could have 2 logs over here that we have to do the same thing as the other side with, but right now we just have that single log. Okay, so let's leave it alone. But over here, when we have a plus, what do we have to do? Right, we have to multiply. So we have x plus 8 times 2x plus 13. Okay. Now, could you drop the logs off at this point? Yes. Okay, I did it later in the previous step. It doesn't matter. As soon as you have a log equal to a log, they can go away. That's fine. Okay. So here we have 4 minus x. And if we FOIL it out, right, we get 2x squared plus 13x plus 16x plus 8 times 13, which I believe is 104. Let's check that for sure. Okay. Now, Notice we do have a quadratic here, so we want everything on one side. So we can use a quadratic formula or factor. Okay, so we have 2x squared, and here we have 29x. Okay. But we need to add x from over here, so we get 30x. Okay. And then we have 104, and we want to subtract 4, so what is that? 100. Now, could I use a quadratic formula like this is? Yes, but I notice that these are all divisible by 2. I like smaller numbers, so let's go ahead and divide by 2. So we get x squared plus 15x plus 500. Okay. Now, we are looking for two things that multiply to 500 and add to 15. So, I don't know. What would it be? Unless I messed up somewhere. Where did 500 come from? Whoops, how about 50? Does that work better? If we have two things that multiply to 50 and make 15? Okay, so we have x plus 10 and x plus 5. Does that work for you guys? Okay. So x is negative 10 and x is negative 5 using that zero product property. And last step, we do have to plug these in. If you put a negative 10 in here, we get 14, which is fine. Okay, but if we put negative 10 in here, we get a negative 2. So negatives are not allowed, so we have to get rid of it. Okay, let's try it with negative 5. 4 minus a negative 5 is 9, so that's okay. Negative 5 plus 8 is positive, that's okay. And negative 10 plus 13 is positive, so negative 5 is good to go. Okay, so let me know if you have any questions. We will definitely look at this tomorrow somehow, whether it be through an assignment or some other little activity, but I will get that to you. Again, these notes should be posted on Google Classroom for you to go along with it, or at least refer to. So let me know if you have any questions or suggestions for how we do this going on. Okay, I will look into live streaming. I'm not thinking Zoom's the greatest thing for us right now, but let me know what you think, and we will talk with you later.